G'day team, welcome back to yet again another video on discrete modeling. We're going to continue on with our precedence networks, however we're going to change it up a little bit and introduce the critical path method. Now this is used for solving more complex problems and finding the critical path through the network. So our networks look a little bit different, but don't worry, they're still created the exact same and they still have the same idea. So our nodes have just become these bubbles, and I'll tell you what these bubbles sort of mean in a little while, but they are just our nodes, and our tasks remain as the arrows between the nodes. So that means this node here is the starting node for B and C. This one here is the end for B. Okay, so it still works the same as the last videos, just we've got bubbles. And the reason we do that is because we're going to put some information in these bubbles. And we do that by performing two scans. So we've got a forward scan and a backward scan. So we're going to determine the earliest starting time for each task, which we get from the forward scan, and the latest starting time, the LST, which would be the backward scan. And this will tell us how much we can delay a task by in order to either minimize the completion time or not affect the completion time, and we'll look at that in a moment. So we'll start with forward scanning. Now the value at the start of the node is always 0. So I always put a 0 in the left hand side of the start node. Then what we do is we add the duration of each task. If more than one task are required, then the largest value or the longest value will be inputted as the EST. So if we come down here, I've got 0 and task A takes 6, so let's say minutes. So 0 plus 6 is 6. Coming over here, let's look at task B now. I've got 6 minutes and I plus 4, so I've got 10 minutes. Looking at C, I've got 6 plus 3, which is 9. Now we see for this node, I've got 3 tasks leading into that node. So I need to check what's going to be the longest or the biggest number. So I've got 10 plus 1 is 11, 9 plus 5 is 14, 9 plus 7 is 16, so I put 16 in as the largest number. 16 plus 4 is 20, and then I'm at the finish. Now that is my forward scan completed. Now you'll see these nodes we've split in half. Now it's important that you do that so we can then do the backward scan in a moment. Now a backward scan is what we use to find the latest starting time of each task such that the project has no delays. We work backwards through the network, so we subtract the duration of the task. And if more than one task leads into a node, we now write the smallest value on the right side of the node. We do, however, record the larger numbers next to the node as we use these to find the slack time for those specific tasks. And I'll point that out when we get to it. So for a backward scan, we actually start at the finish and we input the same value as the LST. So we've still got 20 there. Now 20 minus 4 is 16. The easiest one to do here is task D, there we go, because it's only got 1 leading into here. So 16 minus 1 is 15. Now this is where it gets a bit tricky. Here we take the smallest number when we do our subtraction. So 16 minus 7 is 9. 16 minus 5 is 11, so we take 9, but we record 11 on the task that number came from. So coming here, 9 minus 3 is 6, 15 minus 4 is 11, so I put 6 in the box, in the bubble, and record 11. Now 6 minus 6 is 0. So now we have completed our forward scan and our backward scan. Now I've mentioned the word slack time, and that's how much time I have to sort of delay the task without affecting the overall completion time. Now the slack time of a task is the LST minus the EST at the beginning node of the task. So let's have a look at the slack time for D. Now task D is here, so I go to the node at the start LST is 15, EST is 10. So I've got 15 minus 10, which equals 5 minutes in our case. It's as simple as that. Now it gets a bit trickier when we look for a specific type of slack time. So the slack time for E, so E's here, and the bubble would say it's 9 minus 9. However, the LST for E is actually 11, and that's why we record that value. So I actually have 11 minus 9, which is 2 minutes of slack time. Awesome. Now, I said at the start, this was how we're going to solve complex situations for the critical path. Now, critical tasks, which are the ones that make up the critical path, have LST equals EST. So that means the value in the bubbles at the start are the same. So if we're looking at this network here, my critical tasks are going to be A. Then I come down here because my little number's here. I know I go this way. So I've got C. I've got a little number here, so I go this way, which is task F. And then I finish with task G. So that means my path is A to C to F and to G. All right. And the minimum completion time is the value inside the bubble at the end. Hopefully this helps clear up a bit of forward scan, back scan, and you can now apply it to some questions. Thank you for watching, and I'll catch you in the next one.